So I wanted to make a quick video talking about how I structure my KiCad 5 projects and how I create library and schematic parts. Most of my projects I try to make all of the footprints myself just because I don't like relying on other people's components. And I found a system that works pretty well for me, and I'll go into how I do it here. And I learned a little bit of it from a Hackaday article. I'll link to it in the description. And then I just kind of took what they had talked about and changed some things and made it work well for me. So the first way I start is I use a program called Text to Folders, and it has a text file that you populate with the folder structure that you want. So in this test folder, which is empty, if I hit create folders, it'll create blank folders of everything that's on my text file. So all of these are pretty self-explanatory, but libsch is where all my schematic parts go, and libfp is where all of my footprint parts go. And since I have a pretty well-established selection of library, footprint, and schematic parts, when I start a new project, I'll drag them into these folders. But for this video, I'll just go into how you make your first setup of your library, and then for subsequent projects, you can just drag them into it. So once all of my folders are created, then we can just open up KiCad, start a new project, and start it. We'll just name it test, and in this test folder. So we'll open up a schematic, a blank schematic, and now when you go, let's say you want to make a schematic part, but you don't have a part in your library for it. The part that I'm going to use for this is a pretty common buck regulator. It's an AOZ 1280. So from here we want to create a new symbol from our symbol library, but first we have to create our new library. So with this, we put it into our schematic library, and here you can name it whatever. I typically just name them lib. And make sure everything is project specific so you don't get complications with new projects linking to this one. Everything needs to be specific to the project. So once that's there, we can now create this new part, and in this library, and then name it AOZ 1280. And for these, I typically start with the pins first and then do the actual graphics. So I'll go through and label all of the pins. Okay, so once all the pins are set, we can draw our graphic square around them, and then what I like to do is fill the foreground, fill the background, not the foreground, and it just makes it a little bit cleaner look. And try your best to make the inputs and outputs match what's electrically correct, because it makes it easier when you do a ERC if everything lines up. So once our schematic part is done, we can save it into our library, and now when we go to place a symbol, we have it in our library. And if that doesn't auto-populate our library automatically, what you need to do is go to a project-specific library and make sure it is selected to be our only schematic library. You can have the default ones, but since I again make most of my parts, I only will have the project-specific one that I'm using. So once that is placed, now we need to work on the actual footprint for this part. So we go to our data sheet where it has the package, and what I use for all of my components is a software package. It has a free version, which is all I use. It's called Library Expert Pro, and it makes IPC reflow compatible footprints from common footprint types. All you have to do is enter in the dimensions and it makes the lands for you. So for this, it's an SOT23. So we go here and you just fill out everything that is in this box. So the pitch is 0.95 and it has 6 pins. And then just go through here and enter in all of the dimensions. So once everything's entered, you then can click OK, and this will be the IPC compatible footprint on the screen. So you click the little wrench, select KiCad 5, and then for our output directory, we do the footprint path, which is right there, and then we also want to get the 3D models selection and put our 3D model output. And the naming scheme is again IPC compatible, so create and close, and it populates our footprint on here. And the way KiCad handles footprint libraries, as long as it's a .pretty folder and it has at least one KiCad mod file in it, it automatically considers that a footprint library. So if we open up our main KiCad project, we can go to PCB Layout Editor, and if we want to use that library, all we have to do is manage footprint libraries, project specific, browse, and then we go to our libfp, select it, and now when we go to place a footprint, it will show within our library the footprint that we just created. And what we also need to do is select the footprint, go to the 3D settings, add 3D shape, go to our 3D models, select it, and then typically you have to rotate it on one axis 90 degrees. And if we go to our 3D viewer, it shows our footprint, both the 2D lands and the 3D model. So that is the way that I handle the footprints for common packages. If it's a manufacturer specific footprint, for example, a lot of H-bridges or MOSFETs have unique thermal pads on the bottom. Those you still have to make the footprints the regular way with KiCad, but for 90 to 95% of all the footprints I use the library browser, the library manager to make them, and it makes all the footprints IPC compatible. So that sums up this video. If you have any questions, let me know in the comments or suggestions for future videos. Thank you.